Your next challenge is called Basic Sequence Practice. A sequence or a series in mathematics is a string of objects like numbers that follow a particular pattern. The individual elements in a sequence are called terms. A simple example is 3, 6, 9, 12, 15, 18, 21, where the pattern is add 3 to the previous term. In this kata, we'll be using a more complicated sequence, 0, 1, 3, 6, 10, 15, 21, 28. The sequence is generated with the pattern. The nth term is the sum of numbers from 0 to n inclusive. So look at the example, 0, 1, 3, 6. That's the first 4 from the sequence they already gave us. And you can see it's the sum, so this would be the n equals 0, right? 0 plus 0, 0. Then you go to 1, you add 1 and 0, everything from 0 up to whatever n is 1 because we're at the first index, right? Then it would be 2 here, index 2, so you got 0, 1 plus 2. Then you come to n equals 3 here at this at index 3, and you've got 0 plus 1 plus 2 plus 3. You put the answer in there, and that's how all these numbers. You can continue that pattern if you want to see the rest of them. Your task: complete the function that takes an integer n and returns a list array. They want an array, we can see it in the method here, of length absolute value n plus 1 of the arithmetic series explained above. When n is less than 0, return the sequence with negative terms. So there's a little bit of a catch. And then we see the same examples, right? That was just how we started last time, right? Except now they're going to n equals 4, which would be 4 plus 3 plus 2 plus 1, and then the same thing for n equals 5. Of note, when it's negative, you see that these terms are the same, they just have a negative value associated with them, as they told us. And then 7 is the same thing, just extended out 2 more terms, right? I think that's pretty clear. So go ahead and pause the video, try this one out, and start it back up when you're ready. I'll do 2 solutions. I'll use LINQ first, and then if everyone's comfortable with that, whoever is can leave. If anyone else wants to stick around and sort of roll our own, we'll do that too. So let's get started. I brought the link in to start. And what you could imagine here is that we're going to take a range of numbers, right, from 0 to n at any given point. And for that, we're going to sort of generate a series of numbers based on that n value. In language that we've heard before, I'm going to take that range and I'm going to transform or project it into another sequence. Maybe that'll be a hint for you to see which LINQ method I'll use. But first things first, let's get our range set. We know that the range is going to be the numbers from 0 to n. In this case, it was 5, right? 0, 1, 2, 3, 4, 5. So let's go 0. And then remember, we got to go n plus 1, right, to get up to 5, that inclusive bound there. So feel free to count them out if you don't believe me there. But before I get too far ahead of myself, I'm going to make a temporary variable here. I'm just going to call it the magnitude, right? Because we know that n can be negative, they told us. We saw negative 5 here. And so this is kind of a nonsensical thing when n is negative, right? So let's just get the magnitude of n. And we can use the absolute value function for that. I think you have to bring in the system namespace to use the math class. We'll find out. So at this point, whether you give me 5 or negative 5, the magnitude's still 5, right? And the same with any other positive or negative values. So that's useful. So we're good with our range there. And then when I was talking about projecting into a new, or transforming into a new form, hopefully the select method came to mind. So from our range, we have this set of integers, right? And so we'll make up a variable name for them. We're going to list our parameters here. It's just a single parameter. I don't need the index here, but we did learn that the select method has an overload where you can get the index if that's useful to you as well. But I'm just going to use the element itself, and since there's only one parameter, I don't need to put parentheses around my parameter list. And so what do you think we do with this? Well, it's summing all of the values from 0 up to num, right? And we've talked about this in recent challenges. There's a handy little formula you can use to sum consecutive integers. And so that looks like, maybe I'll just put it in there. It looks like this. It's n times n plus 1 divided by 2. And I had to put the n plus 1 in parentheses because I need it to be added first. If I didn't do that, if you write it out like this, it's going to multiply n by n first, and it's going to add it to the result of integer 1 divided by 2, which should be 0, and it's not going to do what you want it to do. So make sure you use parentheses as needed. And if you're not sure about that formula, you would have known about it if you've been watching the series up to this point. Otherwise, feel free to Google that if you want to see where that formula comes from. There's a famous story about Gauss when he was a kid, summing the numbers quickly from 1 to 100, I think it was. But you can look that up if you like. It's more of a math thing. So, okay, so this is going to transform. It's going to give us the sum that we need. We have one more bit to deal with, though, and we have that issue of whether or not the input is negative or not. Uh-oh, what did I do here? Let me get out of that. There we go. Sorry, I lost my cursor for a second there. All right, I'm just going to call it factor, and basically it's what I multiply the sum by, right? So I'm going to get this value of 1 or 3 or 6, but depending on whether n was positive or negative, I need the answer to be positive or negative. So let's use just a nice short little ternary operator. If n is less than 0, i.e. there's negative input, we'll say the factor is equal to -1, otherwise it's 1. And so we can easily flip the sign as we need to by doing this. And I'm going to group my formula here, and then I'll say times factor, just to make that clear. Okay. So where's my, so that closes, this I didn't want to close select yet. So this closes select. Good. Okay, so at that point, right, we know that select gives us an I enumerable of type int. In our case, that's the generic type we're working with. And we see we need an array. And so what do you do if you have an I enumerable and you need an array? Well, LINQ provides this handy toArray method. And so I can actually return this, I believe. And if I didn't do anything stupid, we should be good here. Let's give it a run. Okay, so we got a problem. Test failed. Values differ at index 0, expected but was 1. Let me take a quick look at what I did here. If we can't figure it out, we'll just put in some console write line statements. So 0, oh sure, I see what I did. So I went to the trouble to make this magnitude variable. I told you when we were chatting that you needed it here, so we didn't put a negative value in there and make this nonsensical term. So let's at least fix that. Okay, so definitely better, but didn't solve the problem. What else am I doing wrong here? So we've got our range, we select, we've got, oh, wow. Yeah, I see it. Hopefully you see it too. So I used num as my variable name, but I used the input parameter name in here. That's not what I meant at all. But, you know, maybe that you learned something there. Like, it's nice to know that you can access some of these variables that aren't in your Lambda, but are, you know, in the scope of the method. Maybe you didn't realize that. I think it was in C++, you have to sort of capture variables like that, or you can. So that's good to know that you can, that they're still available if you actually wanted to reference them. I didn't in this case. I wanted to use each element, you know, that I was selecting. So let's try that. I think I spent too much time in the sun today. All right, there's green. And more green. Cool. So if you're comfortable with sort of making your own and just like the LINQ stuff, feel free to bail here. If you want to stick around, you're more than welcome. And just in case you don't like LINQ, or it's too overwhelming right now, let's just do it another way. Do it manually with our own logic. And so I'm going to save this magnitude and factor variables. As you can imagine, they're still useful. We still need to deal with negative input. That doesn't change by us taking another approach to this. So what I'll start by doing is creating this integer array. I'll just call result. And I'll call it new integer array. And I will give it a size of magnitude +1, just like before, right? We had to do magnitude +1 to get that whole range from 0 to n. And then what I'm going to do is I'm going to initialize result 0 with 0. And then by doing this, I kind of have the starting value, and you'll see when I loop, I always refer back one previous value and build on that. And so I could start my loop at 1. The idea is that you start at 0, and then for each step up in n, you know, n equals 1, n equals 2, you just add the n value that you're on. You just add that value to your previous result. It's like a tally, right? 0 + 1 + 2 + 3, just like we wanted. So then we can make a for loop. And I'm going to initialize I at 1 this time because we already handled 0, right? Our result 0 is good. You know, the rest of the slots haven't been assigned yet, but this slot 0 is good. And then for our for loop, we could say I is less than or equal to magnitude. Let's say ++ I. All right, now we're going to go over you can imagine us going from, we already did 0, from 1 up to n's value, whatever the magnitude of it is. Because we don't want a negative number here, right? We're dealing with positive logic. We're starting low and counting up. And so again, a negative value there would sink us, right? That would be bad for our purposes. So then I'm going to start by saying, at each step, result I equals the previous result. And how would you say that? Result I minus 1. And since we're starting at index 1 in our loop, this is safe. It won't, the lowest I will be is 1. So on that first iteration, this will come out to result 0, which we know is 0, and it will set result index 1 to 0. And then finally, we need to add the value of our current index to that result. And that can be different, slightly different, based on whether our original input was negative or positive. So let's say result I then, it was already set to the previous value. Now we add the current value, right? Plus equals. And then for that, we want to add the value I, and I'll say times our factor, right? Because if it's a negative, that'll multiply this positive value by the negative and give us a negative. If the original input was positive, then it works like you would think, you know. It's gonna maintain the positive status. Anything times 1 is itself, right? It's only when in the negative where you flip the sign of it. So that will let us just go through the loop each time, right? So you started out, I is 1, that's going to add, it's going to set result 1 to 0 on this line because we saw the previous result was 0. And then it's going to add I times 1. Let's say the input was positive 5. So then result I becomes, or result 1 becomes 1. So the first value is 0. You see the second one becomes 1. You step through this, the loop takes care of bumping I up to 2 for you. That is less than or equal to 5. So you come in again. And you start by saying result 2 is equal to result 1. We saw result 1 was 1, so you start with that. And then you're going to add 2 times 1, which is 2. And then you're going to get result 2 equals 3. If you remember from this series, you could see, and feel free to keep stepping through it in your head if you like, or on paper, write it on paper, and you should see the rest of these results come out. Or you can just add a console write line if you want to watch it and see what the console tells you is happening. But finally at the end, you can simply return your result. And so I think this can work. Let's give her a shot. Missed a semicolon. Of course I did. And there we go, green. We don't claim victory until we have the full attempt, and green. So I think I'll go back to my LINQ method, but that's how you could do it if you didn't know LINQ or just didn't want to use it. I wonder how far back I can Control Z this to undo. Hey, there we go. Yeah, and Control Y will do a redo, in case you need to know. So I think that's the line that I wanted. Control Z to undo, Control Y to redo if you Control Z back too many times. Still good? Okay, yeah, green. I'll go ahead and submit. You know what to do. Check out the other answers. Put everything in your tool belt that you can. And then show me whatever you came up with. Pretty similar to what we were doing. That math sign is different, right? Yeah, let me know what you thought. Otherwise, I will see you in another video. Thank you for watching.